Thank you, everyone. All right, so why Google Cloud? Why Vertex AI? Well, first off, it's a deep, rich history of innovation. Google essentially had to invent these technologies to organize the world's data, right? They had to invent search algorithms. They had to invent TPUs. They had to invent the transformer architecture. And at some point, someone decided, hey, maybe we should sell these to other people as well. So that's where we are. A deep and integrated AI-optimized portfolio. So I'm sure you've been having the entire day, the infra stack, the data stack. You have your Vertex, and of course, your application layer on top of that, end-to-end with full flexibility. And we'll get into that during the presentation. And then built on a foundation of enterprise readiness. You can't go to production if you don't have indemnity, security, data governance, compliance. So we will hit on that at the very end. This is a personal favorite of mine, a nice pretty slide right here. But again, everything from hardware to transformers, the T in ChatGPT is transformer, BERT, T5, Bard, Gemini. These are innovations year after year after year from Google DeepMind, from Google Research that have powered this entire LLM revolution. All right. Gemini is our latest model. Now, why is Gemini important? Well, first off, it is natively multimodal. When I say the word apple, you think of something that's probably circular and red. You can probably taste it. APPLE. You probably think of the stock price also as well. The reason for this is because you think multimodally. And the Gemini models were trained from the base. Those layers were trained in a multimodal fashion. So it was text, it was image, it was audio, it was video, all at the same time. This allows you to reason multimodally, and I have some nice, cool demos about that. Additionally, you need to have choice. You need to be optimized while having choice. Gemini models are optimized to run on TPUs and GPUs, but you also have size choices. So this allows you to match cost to use case, and also prompting window choices as well. And up to 2 million tokens as well. And I'll discuss why that's important a little bit later. And when we built Gemini, we actually worked with a lot of different teams. We red teamed them. If you only have people from the Bay Area building your model, it will only understand Bay Area, right? You need context, you need understanding, you need to have different people from different backgrounds so that the models will work for everyone. It's not just a ethical thing, but it's actually a performance perspective as well. And these models are the most safest and secure ones we've ever built at the model level, let alone the tooling that sits on top of it. All right, it's been a long day. I'm just going to show you videos for most of my time here. This one right here is...
This is a demo of long context understanding, an experimental feature in our newest model, Gemini 1.5 Pro. We'll walk through a screen recording of example prompts using a 44-minute Buster Keaton film, which comes out to over 600,000 tokens. In Google AI Studio, we uploaded the video and asked, find the moment when a piece of paper is removed from the person's pocket and tell me some key information on it with the timecode. This screen capture is sped up, and this timer shows exactly how long it took to process each prompt. And keep in mind that processing times will vary. The model gave us this response, explaining that the piece of paper is a pawn ticket from Goldman & Company pawnbrokers with the date and cost, and it gave us this timecode 1201. When we pulled up that timecode, we found it was correct. The model had found the exact...
All right, I want to talk as well. Okay, so what happened here, right? This was a 44-minute video. You were able to upload it, about 600,000 tokens. It took 50 seconds, right? It's a large amount of information, but it did what's a needle in a haystack. You asked it a question in text, find the moment when it took a piece of paper out of it, and it was able to find that in a video. It was able to understand what was written on it, and read cursive and numbers and all this kind of stuff. So that's what we're talking about when we have multimodal.
How long did it take to embed the 647,516 tokens?
So it actually took 55 seconds to upload the prompt. Now,
uploading the prompt and uploading the context.
Yeah.
Two different things.
No. You upload the video as a prompt. It took 55 seconds to. Oh, I mean, there's some networking time to upload it, but let's ignore that. But just the well, I mean, there's a reason. No, there's a reason for that. I'll get to it in a second.
Let me try to understand. So it took 55 seconds for the film to be embedded.
To generate a response. To embed and generate a response. Now, We also have context caching. I have slides on this later, where because you're like, I don't want to wait 55 seconds every time I do this, you can upload it once and then ask it multiple questions over time. And, 24 hours or whatever the context cache is. It saves you money and it saves you latency as well. Okay, now let's do one more little piece here.
Moment, the piece of paper is removed from the person's pocket, and it extracts. This is a demo of long context understanding. Extracted text accurately.
Okay.
Next, we gave it this drawing of a scene we were thinking of and asked, what is the timecode when this happens? This is an example of a multimodal prompt, where we combine text and image in our input. The model returned this timecode, 1534. We pulled that up and found that it was the correct scene. Like all generative models, response is very...
Okay, so this one, again, it'll take about 55, 60 seconds to upload it. It's a little doodle diagram, which actually there's a little bit, there's a bigger version right here. Yeah, so you literally draw something. So this is now image and text and video, and it can reason, again, a doodle and a video and give you a specific response. Again, just imagine the use cases. In fact, I will show you one other demo. I like to take up my time with demos because I am a weirdo, but let's watch this one. Now this one, this is Project Astra. This is from DeepMind. So this is a little bit future looking, but one of my customer engineers actually built this exact demo with a Gemini model. So, is it the future or is it now?
Okay, let's do some tests. Tell me when you see something that makes sound.
I see a speaker, which makes sound.
What is that part of the speaker called?
That is the tweeter. It produces high-frequency sounds.
Give me a creative alliteration about these.
Creative crayons color cheerfully. They certainly craft colorful creations.
What does that part of the code do?
This code defines encryption and decryption functions. It seems to use AES-CBC encryption to encode and decode data based on a key and an initialization vector, IV.
That's right. What neighborhood do you think I'm in?
This appears to be the King's Cross area of London. It is known for its railway station and transportation connections.
Do you remember where you saw my glasses?
Yes, I do. Your glasses were on the desk near a red apple.
What can I add here to make this system faster?
Adding a cache between the server and database could improve speed.
What does this remind you of?
Schrodinger's cat.
All right, give me a band name for this duo.
Golden Stripes.
Nice. Thanks, Gemini.
All right, so what did we see, right? So first off, we saw real-time video processing, multimodal, of course. You saw, understanding of language. You saw understanding of code. You saw the ability to geolocate. Of course, you can integrate this with search, both Google search and enterprise search. You saw that the demise of Google Glass was greatly exaggerated. It's back now, apparently. But again, this kind of gives you the art of the possible, right? When you're talking about a multimodal world.
Now, show me hallucination.
I mean, I can show you a hallucination every single day. Now, every single thing a model does.
That is a beautiful example of, with a few edits in there, of perfection.
Yeah.
Okay. There's equal opportunity that person may have, that model may have misidentified that as not King's Crossing Station, or I'm sorry, I forget.
It's King's Cross. Yeah.
King's Cross. Could have totally misidentified it.
Absolutely.
Okay. So my point is, you at one point said the R word, reason. This is not reasoning. This is math. Okay, it's simply complex math.
It's a stochastic prediction of what it thinks is correct.
Yes, don't use the R word. It's not reasoning.
Depends.
It's not reasoning.
It's not reasoning.
It's mathematics, sir. Respectfully.
Okay.
With all due respect.
All right.
It is. Because it's very complex mathematics. It's beautiful and it works very well. But it's just as likely that there could be a hallucination in here, and unless we paid very close attention, we could be missing something.
So you said it's just as likely for it to be a hallucination. I would respectfully, yes, I would respectfully disagree on the just as likely. What I would say is, I agree.
Correct, not just as likely.
I would agree.
Continue.
I would agree with you in that, yes, I would not want a model to give me a factual response when I need a very factual response.
Okay.
That's why I have search and grounding to be able to actually point back to the data sources that I have, whether it's external or internal. And I highly recommend to my customers, listen, again, if you want a poem, that's fine. Like, you can hallucinate all you want,
Turn
right?
the temperature up.
Exactly. But if it's a medical use case, if it's something where I need something to be grounded and a real answer to come through, you better ground that and point back to the data source, right?
Agreed.
And then also use the check grounding API to tell me exactly how much of this response was grounded in the data source I was using.
I understand.
Right.
I concur with you.
So
Good.
grounding is something Google is focused a lot on, and that's terrific.
Yeah.
I think, a good deal of what we're talking about here is that by the very nature of its training, these kinds of AI systems simulate believability, simulate something that appears correct by the very nature of their training. And that's what they're designed to do.
Mm-hmm.
And so when they are wrong or unhelpful,
They're confidently wrong.
well, they instill confidence in the user by the very nature of that's how they're trained. They're trained to look correct, whether they are correct or not.
Yes.
Yeah.
And that's the grounding addresses that, but seriously, grounding is a concept that even in the practitioner community is, in my sense, not particularly well recognized because of this massive gold rush that we're in right now.
Absolutely agree.
Yeah.
It also goes back to the implementation as well. You're correct. If you build again, these are just APIs. If you build your chatbot or whatever to be confidently incorrect, right? The human brain hasn't evolved yet to actually be able to deal with that, right? When you're talking to a human, if I'm unsure, I give off some sort of social cues where I'm like, right? Like when I'm giving a response. These have not been trained to that. But what you can do, again, is like, listen, I'm a chatbot. I think my response is this. Hey, by the way, this is my source. Again, this is kind of when the RAI and the safety principles and the way you want to ethically design your sources. I agree with you 1,000%.
I know, but this is a level of nuance that is present in 1% of the developers, practitioners, funders, all those people all around us.
We're at the insane hype level, and like.
Well, I've been saying, so now I'm going to say it on this broadcast. I have been saying that a lot of us are already deeply into the trough of despair, just to follow the model, whereas so many of those around us are reaching the peak of the hype cycle, and it's this kind of funny dissonance that allows us to, I think, all of us to really appreciate what we just saw pretty deeply, while at the same time just kind of going, boy, I really hope that's not going out into the wild, even though we already know that it is.
Okay.
Well, and the thing I would like to suggest is that those two examples were impressive in their own ways, but it would be more impressive and more practical if the examples were more grounded in what we really need this stuff for. I mean, do I really want an AI to find a particular scene in a 50-year-old movie? Can you give me?
So two answers to that.
Well, let me
go ahead.
And the other examples too. I mean, you asked the simplest of questions about caching and things. I want these examples to be grounded in legitimate, actual applications that are something you can't do with a regular Google search, that I can't Google today.
So two answers there. One, I have those demos, but they're not as fun. So let's be honest, right?
Like, if you have fun, I'm here to learn about it.
No,
I'm not here to have fun.
But if you're, but a customer service chatbot or a back office for being able to do accounting, like we have those demos, and you can look at those as well. They're more practical. I'll be honest, right? Like it's less fun than showing like a really cool Google Glasses demo. But I agree with you in that. Like what you want to do is you want to match the use case to the actual productivity and the KPI you want to achieve, right?
Yes.
My concern oftentimes when I'm meeting with customers, they'll see that and they'll be like, hey, can I do that for every single thing? And it's like, you could, it would cost an arm and a leg. Like, why would you want to do that, right? Now, funnily enough, when you're saying I want to find a 50-year-old little clip in a video, I actually have customers, think of sports highlights, where they want to actually find a specific clip.
Use that as the example and not the guy under the water tower in a 60-year-old movie.
You don't like Buster Keaton?
It's public domain, that's why you can use it. Anyways, okay, all right. Oh my God, I'm down to 9 minutes. This is crazy.
But it was a good defense.
That's why they bring me here.
That's in your face.
Okay.
We're here too.
I know. Okay, here. So this is Vertex platform. I'm going to skip infrastructure and data cloud because everyone has been covering this. I'm just going to focus on the middle section right here, Vertex AI. Let's start with the model garden. This is where you start your journey. Again, I just showed you the flashes and the pros of the worlds, and I'll talk about the differences there. But it's not just Gemini. You have your foundation-specific models. I'll highlight Imagine 3, which is text to image. You also have things like Cody. To your point, hey, I want to do code completion or code start. You can use Cody embeddings, things like that. Task-specific models haven't gone away. If you want to do a translation task, it's cheap, it's easy. Why do you need a massive model? Domain-specific models, MedLM in the healthcare space, SecPom for security. You may have heard of LearnLM, which is the newest one that just came out of DeepMind. That's for the educational space as well. And then partner ecosystem. I really want to emphasize this. Like, I'd love you to use a Gemini model, but I do not care if you want to use Llama, you want to use Claude 3, you want to use a Hugging Face integration. We want you to pick and choose whatever model is right for you. We also give you the tools to compare and contrast them as well. So again, to your point, task-specific model, you may want to swap them out. And of course, Gemma, which is our new open family of models, which are doing some crazy stuff, and the performance is actually getting kind of out of hand in a good way. And I'll get to that in a second. Okay, so just quick announcements again, because we do not have time. But what did we announce? Gemini 1.5 Flash just went GA. Why is Flash interesting? If you look at LMSys, the rankings, and if you kind of map them as a price to performance, it's right in the top right corner. It actually breaks the chart. So you get amazing performance almost to the top of these massive models at like 10x, 20x less cost. So Flash is very, very exciting from that perspective. Of course, comes with your 1 million context window there. You have Gemini 1.5 Pro. Larger model for more of those complex tasks. It says the word reasoning there, but we can debate that later. This is up to 2 million context in private preview. Now, again, why would you ever need 2 million context? You have an hour, 2-hour video. You're like, listen, I want to find the highlights and then do it quickly. You have code transformation. You have an entire code base and you're like, I want to do this. You can actually start doing this with these large models. You have tons of, like, let's say 10Ks. These are financial works, and the cost, right? It's like $300 an hour for the analyst to do this. You can do some really interesting stuff. Now, I'm not saying fire that $300 analyst. I'm just saying run this, have them come in, do the searching and that stuff, and have them verify. Right? Again, this is the thing I'm saying. Don't trust the model all the way, but it can help improve productivity. Now, don't forget about Imagine here as well. So Imagine 2, all the stuff you see in your Pixel phone where you can delete a person from the picture, you can expand it, all that stuff's available in Imagine. And Imagine 3 is right around the corner. I can't spoil stuff because there's a stream, so I can't tell you anything. And then VO, as I like to say, I'm from Los Angeles, the coming summer 2024. VO is our text-to-video model. I have gotten so many inbounds about this. But again, Imagine 3 and VO, high quality, human faces, just in the quality is impressive, very, very impressive on that. And of course, all of this comes with safety in terms of content moderation and human generation and child generation, things like that. But anyways, just wanted to mention this. I talked about Gemma. Again, Gemma is our open family of models. Now, someone might ask, what's the difference between open and open source? It's basically Google's terms for open models prohibit some specific use cases. It's, don't do terrible stuff with it, essentially. But other than that, you are free and clear to use these. These are open weights. You can, run free with them. Again, you have Gemma. I think the 27B model is actually amazing state-of-the-art performance there as well. You have different formats. I think recurrent Gemma was recently released within the past week or so as well. So again, for the developer, for the researcher, for people who want to really play around with these open models, I highly, highly recommend Gemma and that family. Okay, so that was Model Garden. That's where you kind of find your models. Now, Model Builder. The thing I want to emphasize with Model Builder is that this is predictive and generative. Generative is taking up all the air, all the hype, but predictive use cases still make a ton of sense, and I've seen a lot of customers do predictive and generative at the same time. You might start with a predictive model that feeds into your generative model, that then feeds back into a predictive model, and you need the ability to kind of like pipe these together, right? So you want to start, again, I'm not going to cover this, but with your data stack, your BigQuery, your Dataplex, through the foundation models, you want to use pipelines, you want to use RAG, you want to use a model evaluation, model monitoring, feature store, model registry. You want a platform that works across this, and of course, with your notebooks, with your Colab Enterprise, with AI-assisted Gemini, so it can code for you and help you. You can do, again, your data tasks, your predictive tasks, and your generative tasks all at the same time. Just a quick shout out here. Again, Rayon, Vertex, PyTorch, and SaxML. These are open frameworks that are managed for you as well. Again, we are improving the predictive stack while we are improving the generative stack as well. Just a quick shout out to this one. And then, of course, prompt management allows you to, again, manage your prompts, improve your prompts. AI-assisted prompting, where it actually can tell you, hey, you should probably rephrase this in this way. Super interesting stuff here. This is kind of the ML ops for large models. And then generative AI evaluation. I just showed you, what was it, like 20, 50, 150 different models. How do you compare them? You want to use auto side-by-side, which uses another AI model because now AI is running everything. But you want to compare model A to model B at scale to be able to evaluate these different models and different use cases as well. Super important. Okay, a bunch of improvements in terms of customization optimization. Control generation. Hey, I only want JSON output. I only want XML output. You have that. Batch APIs, right? This is cost-saving stuff. Hey, I don't want to do online prediction. I want to do batch. I want to schedule it. I want to have less cost. Okay, and then we mentioned context caching. If you're dealing with 1 million tokens or massive amounts of tokens, you want to cache the context and be able to ask multiple questions, and then we will pass the cost savings on to you. Up to 50%, I think, is the reduction in cost, and of course latency as well. So again, these are the kind of meat and potato improvements that are very, very important to make something actually cost-effective and work. All right, Agent Builder. This is our no-code, low-code, full-code layer for the developer. Think of this as tooling and pre-built primitives where you can do your orchestration, you can do RAG, you can do manage llama index, LangChain, you can do grounding, you can do search, you can do connectors, you can take extensions and function calling, and again, things like doc processing, retrieval engines, ranking engines, allow the developer to access this generative AI tooling and being able to connect it with all the other stuff, whether on the no-code, the low-code, or the full code. A few things to highlight in this one. Again, LangChain on Vertex AI, public preview. You have Llama Index on Vertex AI, public preview as well. Firebase GenKit, so this is kind of the stack atop this. So it's essentially the application layer, the app developer layer, we're kind of infusing that with generative AI as well. So that's why you see with the Vertex AI evaluation of Firebase GenKit. Of course, grounding. You can ground on Google search for real-time factuality, or ground on enterprise data for when you actually need something to be 100% factual because it's your data and you want to ground that there as well. So you have that choice to be able to do that. And of course, parallel function calling, again, being able to run multiple functions at the same time in a single turn. Very, very useful here. Okay, ooh, I have 1 minute, I made it. Okay, finally built on a foundation of enterprise readiness. Now, this is important. Again, like the developer might not care about this, but when you're talking to a Fortune 500 company, they want to know, I won't get sued. I want to know my data I'm using to train the model, to tune the model, to use it will be protected, will not be used by Google or anyone else. I want to have privacy. I want to have security, customer managed encryption keys. I want to have data residency around the world, whether in flight or at rest around the world. And again, I can spend a ton of time talking about this. And of course, tooling as well for security, safety for responsible AI. So can I manage the output? Can I make sure that there's copyright protection so that it doesn't accidentally spit something out? Can I configure that, and then can I apply it to third-party models as well, not just the Google first-party models? And of course, shout out to the adapter layer here. If you ever wondered how you can tune a model, make it customized while protecting your data, it's this adapter layer concept. So the model sits here, the adapter layer sits on top of it. That's in the customer project, and all the changes, the distillations, the reinforcement learning, the LoRa tuning happens in the adapter layer, and then the adapter layer gets sent to the foundation model. So that's how you do it.
Can I ask you a question? Is it okay to ask a question?
You have like 5 seconds apparently, but yes, absolutely.
7?
Yeah, go ahead.
I have an SAP environment here.
Yeah.
It's got databases for HR, ERP, manufacturing, sales, paychecks, all this other stuff.
Yeah.
I want to be able to somehow bring that context into Vertex and ask a question, what's my best sales rep in Illinois?
Yeah.
Can I do that?
Yes.
Yes?
Yes.
No code, low code, real code?
So I'll give you I'll give you a little confession here. You can do it. The problem is you can do it in too many ways. And then the customer is like, okay, well, which one's the best? I'm like, listen, I don't know. Like, we're trying to figure this out
I'm just
ourselves.
interested in getting this done.
No, so I agree with you 100%. But there are different ways of doing it, but you can definitely do it. So, for example, one thing you could do is you could use a connector. So you could, for example, tie into the SAP database, and if you know where that, you can have the LLM be like, hey, I'm going to go here and pull this information through a connector and bring this back. Maybe with a function.
It's doing effectively like sucking in the context of that database.
So this is it's not
embedding it and all that other stuff.
It's not embedding it. It's literally loading the data. So you could use a function call in the connector to be literally like, hey, go sort this column or do a SQL
We're talking
query.
terabytes of data, right? I mean, stuff like.
Well, I don't know about the exact size. Terabytes maybe. No, I mean that's a fair question. I'm not an expert on like the search stack, but that's one example. To your point, if it's terabytes of data, there you might want to go over back to enterprise search or vector search and vector embeddings to be able to kind of drive that result. So there you either do pre-grounding or post-grounding, where now instead of pulling data, you're embedding the result from the data, from the search result into the LLM and then producing an answer, and then theoretically linking back to it, right? So again, to your point, it's highly contextualized, highly context-specific. How big is the data source? You can even, again, I have customers where they're like, okay, do I do RAG or do I just dump everything into the 2 million tokens or 1 million tokens and do it? And I'm like, I don't know. Like, we're trying to figure that out ourselves, right? Because studies have shown, like there's some papers that the large context can actually outperform RAG, but it costs more and it can be slower. So where's the breakoff point, right? Like, how big does the data source need to be to do RAG versus to be doing large context? This stuff is moving so fast, and this stuff is getting invented so quickly. Like, we're still trying to come up with the best practices there. So again, my short answer to you is yes, you can do it, but you probably have to spend some time either tinkering or experimenting or understanding, hey, what are my options? And then comparing to what you're trying to achieve. And again, what's the characteristics? Like, to your point, if it's 4 terabytes, maybe connectors doesn't make sense because you won't be able to like do that quickly. Maybe you want to run a search. Maybe you want to train that 4 terabytes into an embedding space that might be more performant and then run it in that use case. So again, there's trade-offs to be had there. And that's kind of like why we oftentimes have to like work with people and be like, hey, let's actually like experiment and understand how these things are evolving and working as well.
That's the conclusion I'm just reaching, is that an organization either needs somebody in-house who speaks AI, so to speak, or has to hire services.
I mean, let's be honest, right? Like, this stuff is moving so quickly. Like, there's no game plan, right? So a lot of the stuff is just you're like, oh my God, this just got invented. Let's go and like figure out how it works, and then understand how to integrate that, and then make it productionized. That's the other piece, right? You do a POC and it works great, but then you're like, I want to scale to like 4 terabytes. I'm like, uh-oh, it just broke everything, right?
Or test if it's ready for production.
Or if it's ready for production, right? Like, to your point, right? Like, when you were like, hey, the model, if I'm deploying a chatbot, like, okay, like I can prevent it from cussing, but like if it gives a guarantee to a customer, like because it pulled the data from the wrong source, right?
And
or hallucinated.
Back to Ray's point, by the way, Ray, that data is behind your corporate firewall. Where does that data that gets summarized, does it end up inside here, or does it stay there?
Yeah.
That's another question too that I think Ray and database administrators and security administrators would want to ask.
And I can tell you, like, it'll never be used to train the model, but to your point, right? There can also be like they had residency issues where it's like, listen, like it has to be
like
I have sovereignty and all the regulatory piece, like all these things as well. Like I can't copy the data; it has to stay in region or has to stay in database. So there are those like myriad complications on top of that. Again, the tech is in the like cool phase right now, but like the practical stuff is where you're actually gonna drive real innovation as well. So
I mean, don't get me wrong, that was an impressive demo.
So
that was pretty cool.
Anyways,
especially the Schrodinger cat.
I know, right? I'm a physics minor, so I was like,
my favorite. That was good. That was cool.